There are two major concepts behind the trick, that is surface tension and air pressure. You see, when the handkerchief was loose, water molecules could easily pass through the gaps of the handkerchief, thus causing water to pass through the handkerchief itself. However though, when the handkerchief was pulled tightly, this allowed the water molecules to come together and form a layer, a property which we call surface tension. This also happens because of the strong cohesive properties of water. Furthermore, there is another factor which we call air pressure. Air pressure comes in all directions, up, down, left, right, northeast, northwest, all directions. However though, since the layer is a uniform surface, air pressure was applied uniformly that allowed these water or water molecules to overcome the power of gravity. Thus, with the help of surface tension as well as air pressure, water did not pass through the handkerchief and was also able to overcome the power of gravity. There is only one concept behind the trick, two words, and that is surface tension. You see, when a balloon is inflated, the rubber is stretched so much that its overall surface tension is very, very tight. Thus, when this overall surface tension breaks, it easily pops, the balloon easily pops, thus causing a loud or surprising sound. However though, there are two regions in the balloon, or more commonly two regions in the balloon, that have a very low surface tension, and that is the top region of the balloon and the bottom region of the balloon where the nut is found. Now, thanks to this low surface tension region, it allowed us to puncture a barbecue stick into the balloon without popping the balloon, without making much of a sound, and without deflating the balloon. That is because these regions have a very, very low surface tension that it did not directly or rather immediately affected the overall surface tension of the balloon. Thus, we were able to do the trick. The trick was made possible because of atmospheric pressure. You see, when the newspaper was laid flatly or uniformly on top of the ruler, the atmospheric pressure acting on it was applied uniformly on the uniform surface of the newspaper. And since the newspaper has a very, very large area, the pressure acting on it was able to overcome the force that is acting on the ruler. Thus, the ruler stayed in the table. Compared to when the newspaper is folded, there is a lesser area, thus there is a chance that the ruler might fall off next time a force acts on the ruler, since this time the pressure acting on the newspaper is now smaller. There is a bit more of chemistry behind the trick, but first we will discuss a simple air pressure effect behind the trick. You see, when the matches was put inside the glass, the air became hot. However, when the matches was put out, the hot air cooled down. Since cold air takes up less space, this caused water to be sucked up to fill in that extra space. Secondly, there is combustion. Combustion requires oxygen, and this combustion reaction produces carbon dioxide and water. However, water is more likely to condense into liquid So the gas that remains is carbon dioxide. And since there is lesser gas, this causes water to be sucked up again into the glass to fill in that extra volume. And that explains the concept behind it.